In this chapter, we will make an introduction to cryptography and the course in general. We will start seeing what cryptography is, then we will continue with the goals we want to obtain by using cryptography, then some differences between cryptography and some areas that are related, like coding theory and steganography, and then we will start focusing on encryption schemes and some basic definitions there. We will end the chapter talking about Kerckhoffs's principle and in general about security. We will start with cryptography. Cryptography provides solutions to keep the content of our messages or files secrets, to prevent their content from being modified, or helping us be sure who sent a message, among others. In this course, you will be introduced to the basic concept of cryptography, from classical schemes to public key cryptography and the most recent schemes. Also, we will see their main applications and all the mathematical concepts involved. We will see topics like stream cipher, block ciphers, public key encryption schemes, or digital signatures. So let's start with the concept of cryptography. If we look at the word, cryptography comes from cryptos and graphos. Cryptos means secret and graphos means writing. So etymologically, cryptography means secret writing. In general, cryptography encompasses all the techniques allowing a secure communication when there are adversaries. Originally, cryptography was mainly used by the military because they want to prevent their enemy from learning information exchange. As you know, nowadays, cryptography is widely used in our everyday life to guarantee secure online communication, electronic commerce, confidential data storage, and so many other things. In cryptography, we can distinguish between these three terms. When we talk about cryptography, we mean the study of the mathematical techniques for all aspects of information and communication security. On the other hand, if we talk about cryptanalysis, it is the complementary science concerned with the methods to defeat these techniques. That means trying to break it or find the problems that the scheme might have. If we talk about cryptology, we will mean the study of cryptography and cryptanalysis. Normally, the terms cryptology and cryptography are used indistinguishably. So when we talk about cryptography, we might also mean cryptanalysis. Now let's see what are the main goals of cryptography. When we talk about goals, we mean the objectives we want to obtain for a protocol to be secure. But what does it mean for cryptographic schemes to be secure? The main goals of cryptography would be to guarantee confidentiality, authentication, integrity, and non-repudiation. There are more goals, but we will focus mainly in these four in this course. Confidentiality means avoiding the adversary from knowing the content of a message. So we try to keep the content of a message secret to the people we don't want to know. Then, with authentication, we want to make sure that the user is who he claims to be. So if we have a document that is supposed to be produced for a person, we want to make sure that it was this person who produced it and who sent it. With integrity, we want to make sure that the content of a message has not been altered. And with non-repudiation, we try that users cannot say that they have not participated in a protocol when they have. Let's now see some examples on each of these goals. So in confidentiality, we have two parties that want to communicate over an insecure channel. The goal that we want to obtain if we want a protocol to be confidential is to provide a method of communication such that an eavesdropper doesn't learn the information exchange. For example, we want to have confidentiality when we send our credit card number to an online shop. We don't want anyone from learning this number, so we want that this protocol is confidential. Also, in a war setting, if we send our troops a message specifying some instructions for the attacks, for example, the message attack at dawn, we wouldn't like our enemies to know that, so that they are not prepared. Let's now talk about integrity. If Alice wants to send Bob a message, and she doesn't want the message to be altered, then she wants to obtain integrity. So this goal tries to prevent the content from being modified either accidentally or deliberately. No one should be able to substitute a false message for the original message or any part of it, or alter the message in any sense. Imagine, for example, that we want to make a bank transfer of some amount of money, and the adversary wants to change the amount of money. Maybe they want to change $10 by $100,000. We don't want that, so integrity will allow to prevent this thing happening. When we want to obtain authentication, we want to make sure who sends the message. So if Alice wants to send Bob a message, she wants him to be certain that she was the one sending it and originating it. We want to prevent an adversary from impersonating anyone and forging messages. Imagine, for example, that your instructor sends you an email about a test. The adversary wants to pretend he is the instructor and send wrong information. So if the message is authenticated, we will make sure that it's the instructor who sent the message and nobody else. Authentication is also important for access control, if we want to know who exactly is able to access some resource. And this is also useful for signature authentication. So with authentication, we will try to mimic what happens with signatures in the real world, but digitally. With non-repudiation, what we want is to prevent the sender to say that she has not participated in a protocol or she has not sent a message when she does. Imagine, for example, that you sign a list for a year and then you say that you didn't sign that. So you don't want to keep on being in that property.